Hey, geometry folks, this is Miss Soli here with 1.7 writing proofs. Everything in this chapter is so far has kind of been leading us here. We're gonna bring everything we've got here together. Writing proofs today, and the very last day of Unit 1. Okay. Turn to a nice blank page here. 1.7 writing proofs. All right, now proofs. A proof is a thing in math, a very memorable thing. If you ask anybody about a proof, they'll likely know what you're talking about. A proof is a logical argument that shows a statement is true. A logical argument that shows a statement is true. And this is where I think math starts getting really creative. With a proof, I'm going to tell you where to start and I'm going to tell you where to end. But how to get there kind of is up to a couple interpretations. Proofs can be really elegant depending on how they're presented. And we're going to focus on the 2-column proof for the rest of this unit. But in the next couple units, we'll try some other types of proofs. 2-column proof is just a very organized way. It is numbered statements that match reasons, that correspond to reasons. And I'll explain what that is in a second. Okay. So a proof, a logical argument that shows what's true. 2-column proof, it's just nice and neat. Okay, before we start, I'm going to define a couple things, and some of these, I hope they sound pretty familiar to you. This is not something that you've maybe had defined in a long time, but you know what these are. These are algebraic properties of equality. Okay. Algebraic properties of equality. And these, like I said, they're going to feel kind of like they make sense. Okay, I'm going to give it a fancy underline because there's 5 that fall under it. So I've got the addition property of equality, but I'm not going to write that for everyone. The addition property of equality. This one just means you can add the same thing to both sides. If A is equal to B, then A plus C equals B plus C. You can add the same thing to both sides. Similarly, the subtraction property. It is exactly the same. If A is equal to B, then A minus C, A minus C is equal to B minus C. I can subtract the same thing from both sides. As long as it's the same thing. Both sides of the equal sign is great. How about any guesses what the multiplication property of equality says? Anybody? I shortened that this time. I forgot a whole piece of that word, multiplication property. It's the same thing. If A is equal to B, then A times C is equal to B times C. You can multiply the same thing both sides. Does anybody know what's next? I know you know. I know you know what's next. It's the division property. That's what you were thinking, right? The division property of equality, again, is a very similar one here. If A is equal to B, then A divided by C is equal to B divided by C, except you can never divide by 0. So I have to throw that in there, except C cannot be 0. Anything else? Anything else you can divide both sides by. Cool. There's one more, and this one's a little bit different to give you a little variety, and then we'll do an example. The distribution property of equality. And this one, it'll look familiar to you. So distribution property if, or I guess no if, sorry. A times the parenthesis B plus C. I can write this as, if I distribute the A times B plus A times C. Okay. So these are the properties. None of these should be new, but we're going to use them in a really formal way. And this is really important for communicating. If you're going to prove something, you need to be able to justify your statements. All right, so I'm going to pop this into an example of a 2-column proof. Fun. Okay, over here I'm going to have what's called statements. And over here, I'm going to have what's called reasons. Each statement needs a matching reason. We're going to keep organized with this flow chart, if you will. Okay, and we're going to start up at the top. So statement number 1, I'm going to give you this. I'm going to say 2x plus 5 equals 20 minus 3x. The reason we know this, it's given. Every proof will start with the given information. All right. Now, I am going to manipulate this equation here to get to an answer, to get to a conclusion. So I'm going to do step number 2 here. I'm going to write 5x plus 5 equals 20. Take a moment, see if you can see what I did. I added 3x both sides. Did we see that? I'm just going to put a tiny little bit over here. Plus 3x plus 3x. I added 3x to both sides. So what property did I use? If I added the same thing to both sides, I used the addition property of equality. Huh? Okay, statement number 3. I'm going to write 5x equals 15. What did I do? What changed? Looks to me like the 5 is gone. Did I subtract the 5 from both sides of the equation? 20 minus 5 is 15. Yes, I did. What property is that? Well, that's the subtraction property of equality. Okay, x is not alone yet, though. I'm going to write step number 4 here. X is equal to 3. What did I do here? What did I do here? To get x by itself looks like I divided by 5, both sides. And 15 divided by 5, that is 3. The property I used here was the division property of equality. And this is the conclusion of my proof. So where I started to where I ended. And usually I'm going to be telling you, this is where we're starting, this is where we're ending. Get there in whatever way you want. This is a 2-column proof. Okay. Now I've got two more properties to add, and then we're going to do a geometry one. This one I feel like is a real algebra heavy proof. I'm going to show you what this is going to look like for geometry here. Okay, I've got two more very common properties you're going to be seeing a lot. Substitution property. If A is equal to B, then A can replace B. In an equation or an expression. Let's just say equation. Substitution. And that makes sense, right? If x is equal to 2, then I can put 2 wherever I see an x, would be something where I use substitution. And the other one here is called transitive property. And this one, transitive, transport, transverse, right? I'm going through something. So a transitive property, now follow my journey here. If A is equal to B and B is equal to C, then A is equal to C. This property reminds me a lot of the law of syllogism. And the law of syllogism is just talking about, though, in words. We use transitive when I'm talking about equations. They're really the same thing. Okay, let's do one example with an angle. This is going to be fun. Okay, all proofs are going to kind of look like this. Usually I'll give you a picture. So I'm going to give you this picture here of, we're going to have, here we go, A, B, C, D, and E. Angle 1, 2, and 3. Okay. So this is what a proof is going to look like. It's going to give you a picture, usually with nice labels. And then it's going to say down here, given the measure of angle 1 is equal to the measure of angle 3, prove to me that the measure of angle EBA is equal to the measure of angle CBD. Okay. So measure of angle 1 is equal to 3, given that that is true. I don't really know anything about angle number 2, but given that this is equal to this, prove that angle EBA is equal to CBD. I'm just underlining that one because that highlighter's darker. Okay, let's make a 2-column proof here. Here's my 2-column proof. I've got statements, and I've got some reasons. It's going to be a little bit tight. All right, now with our statements, we're always going to start with the given information. Number 1, given. The measure of angle 1 is equal to the measure of angle 3. That is given. I don't have to work for that statement. It's there. Now I'm going to flash back to, I think we did this on 1.2. So I need to figure out how we're going to get to my proof. And we're going to do this all together for quite a while now. I'll like give one blank or the other. You're not going to have to do it all on your own just yet. But let's say that the measure of angle EBA is equal to the measure of angle 2 plus 3. the measure of angle EBA is equal to the measure of angle 2 plus 3. Now, we learned about this. Let me just flip back real quick. Yeah, in 1.2, the angle addition postulate says if I've got a whole big angle, it's equal to the part plus the part. So the reason that I know this is true is because of the angle addition postulate. Oof. Okay. Ooh, interesting. Now, I think I can say the same thing. Number 3, I'm going to flip it though a little bit. The measure of angle angle 1 plus the measure of angle 2 is equal to the measure of angle CBD for the exact same reason, right? CBD is angle 1 plus angle 2. Angle addition postulate. Part plus a part equals the whole pink angle here. Okay, great. Now, step number 4. I can write here that the measure of angle 3 plus the measure of angle 2 equals the measure of angle CBD. Does anybody see what change I made? So from step 3 to step 4, noticed the only thing that changed was the measure of angle 1 became the measure of angle 3. Why am I allowed to do that? Because in step number 1, I said these two things are equal. So now I can replace one with the other whenever I want. That's substitution. Okay. And my last one here. Okay, so now I can jump. The measure of angle EBA is equal to the measure of angle CBD because, let me get my yellow highlighter. If EBA equals 2 plus 3 and 2 plus 3 equals CBD, then by the transitive property, those two things are equal. And that is a proof.